welcome back to another exciting episode of everyone's favorite class, Pre-Calculus Graphing Trig Functions Edition. I know you've all been waiting for this, so let's get started. We're going to do two things today. We are going to introduce sine and cosine's parent functions. When you go to graph a trig function, one of the things that we are able to do is we're able to learn their parent functions. Basically, what does just traditional sine of x look like? So if we start out with something like this, how do we graph it? Well, we're going to start out kind of slow, and we're going to identify a few things that are key elements in graphing trig functions. We're going to start out, we're going to do this in two parts. Today we're going to talk about amplitude and period, and then we'll add in the other elements next time. So amplitude is essentially the height of the graph, right? And so for all graphs for sine and for cosine, they use something like this. So amplitude, all right, is equal to just the absolute value of a. And for all these letters that I'm about to use, I've written down the parent function on the left side of the screen over here, so you can see it here. So we have an a times sine, we have a bx minus h, and then plus k on the outside. So if you remember back from when you learned about transformations, shifts, vertical shifts, horizontal shifts, stretches and shrinks, all of that kind of stuff, that's what we're going to be doing. But these graphs are a little bit different. They go left and right. They're called periodic functions, and they don't have technically an end to them. They repeat themselves over and over and over, hence the name periodic. So we have to treat them a little bit differently, especially with phase shift, which we'll learn about later. So whenever you have a trig function, or especially with sine, we're looking here at this value right in front of a, right in front of sine. Right? So for this over here, my a value is real simple. In this case, we have an a equal to 1. My b is the value in front of the variable. In this case, I have x. Sometimes you might see theta. Sometimes you might see some other weird Greek letters. It doesn't really matter. This represents the angle measure. But the number in front of that is what I'm going to be paying attention to, right? So there is there's always an understood 1 in front of a variable without a number, right? So b is also 1. So whenever you get a graphing question option, you're always going to want to label these a, b, h, and k, because that's what's going to determine what my graph looks like, a, b, h, and k. For today, we don't have h and k in this question are both 0, so there's 0 horizontal shift, or what we call phase shift, and there's 0 vertical shift. So I don't really have to worry about all that. We'll take care of that next time. Period, for sine and cosine, period is equal to 2 pi divided by whatever b is. Right? These are things you definitely want to learn. You'll use this enough where I would say you need to memorize these. You should use this enough just in basic practice that it's just kind of automatic. So pay attention, do enough of these that's going to make a lot of sense. So what I'm going to do here is I'm going to show you how I graph these trig functions. For the parent function, now this is just for literally just y equals sine of x, right? So y equals sine x, 1 sine of 1x. We're going to call this the parent function. Sine, if you think about this, what we're going to do is we're going to put the angle measures around the unit circle on the x-axis. So we're going to put 0, then we're going to put pi over 2, right? We're going to kind of go along the quadrants. This would be pi, and then we're going to put 3 pi over 2, and we're going to go all the way out to 2 pi. This would be one full rotation all around the circle. So what I'm trying to figure out is where does sine and cosine go as we move around the circle. If you want to look along on your unit circle, this is going to make a lot more sense when I'm talking about that. So grab your unit circle real quick, pause the video, and come back when you have it. Okay, so if I'm looking at 0 degrees or 0 radians, I would like to know what the y value, because the sign of the trig functions around the unit circle is the y value of those coordinates, right? So sine of 0 is 0. And so we're going to mark these in red, right? So we're going to put a mark there. We're going to put sine of pi over 2. So what is sine of 90 degrees? Well, the y value there is 1, right? So we're going to go ahead and we're going to mark our y-axis. We're going to go up to +1. We need to mark more, we will. We go up to 1 right there. If I go over to pi, I'm going to look at the y value of pi. Well, that's back at 0 again. All right, if we go to 3 pi over 2, that's straight down, that's 270 degrees. If I look at that one, I'm going to get a y value of -1. Okay, and so we'll add that point into the bottom here. And then if I go back to 2 pi, well, that's kind of where I started from, so that's already back at 0 again. And if I look in between, let's kind of go halfway. I'm not going to mark that in the x-axis, and you might want to grab a calculator for this one. If I go halfway between 90 or 0 and 90, that's 45 degrees, right? We have a square root of 2 over 2, right? So that's like 0.7 something, right? So we're going to mark that. We're going to get close. So halfway between 0 and 1 right here, we're going to go up to about 0.7. So somewhere right in here to make a mark. So we'll make a mark right there. If I go over to the 45-degree angle in the third or in the second quadrant, I'm going to find that's going to be the same thing, 0.7. So I'm going to put another mark here. Go to the third quadrant, and you're going to find out that the 45-degree angle, which is 225, or 5 pi over 2, that's going to be -0.7. So that's going to be down here about there. And you're going to find out again, if I do the same thing again, let me get in the right spot. I'm going to have the same kind of thing. So you get to see a pattern taking shape here. And I could continue, if you wanted to add in angles, like you could do, what's the sine of like maybe 30 degrees or 15 degrees or 10 degrees or 5 degrees, and you would be able to build this up. Now we don't need to because we obviously can already see what's happening. I'm going to go ahead and I'm going to fill in the curve that takes this pattern. Right, so going up. Notice that I'm not making a rigid pointed graph, right? This is a smooth curve. When it comes to the bottom, it's smooth and it keeps on going, and these patterns keep going forever. If I continued to make these dots, I would continue on making the exact same pattern over and over and over again. Right? Just to illustrate that, I'm going to keep it going out just to show you what 2 full periods would look like. So I'm just going to put these marks out here, right? I'm going to put 4 more marks. I'm actually going to get to 4 pi this time, right? So this would be like 1/2, 2. Let me get my pointer out. This is 1/2, 2 halves, 3 halves, 4 halves. This is going to be 5 halves. Let's just kind of do the fractions here. It's good practice. 5 halves. This will be 6 halves, but that's just 3 pi, right? So 3 pi here. And then 7 halves. That doesn't reduce. And then 8 halves. I'm just throwing that pi in there because it's always there, right? And that reduces, right? So I'm gonna kind of erase the ones that reduced. I don't need those. I could keep going. I could even go backwards across the y-axis and keep this going. Of course, it would be upside down because it's going to be heading up, but we won't get there. And so if I were to keep this going, right, I'm not going to add in all the points like we did last time, but we'll just kind of estimate those values. That'll be okay. And so you can see it here. You can see the parent function of sine. Let's talk about a few things that's important. Number 1, where does sine start? It starts at the origin or on the x-axis. Okay, something to note, the line that you can draw right through the center of your trig function, right? In this case, we see it right here. This is called our midline. That's going to be important a little bit later on when we talk about vertical shift, but for now, just note that that's the midline. All right, so we know that it starts at 0. It maxes out at pi over 2, kind of goes straight from the 0 all the way up. Okay, it maxes out at +1, and it's going to head back down, and about halfway it hits the x-axis again. And then it minimizes 3/4 of the way through, right? Here we got 1, 2, 3, and then 4. So 3 of the 4 steps it minimizes at -1. And then it's going to go back up to 0, and then it repeats itself forever. Okay, let's define a few things. Number 1, the distance from the midline to the peak. Now this can be up or down. This is called the amplitude. The amplitude is the distance from the midline to its extremes. So it's midline to its maximum or its minimum, because it's going to be the same thing. Hence, I have an amplitude of 1. If I were to change this, right, if we had an amplitude of 2 or 1/2, let's do the 1/2. I think I'd run out of room if I did the 2. And so if we did a 1/2 amplitude, so here is 1/2. If I had something where I had to write out a sine function where it was y equals just 1/2 sine of x, then this is what we would see. I would see a function where it only goes up to the half. Nothing else is going to change. I'm just going to, let me do this one in blue so you can see the difference. Is this going to work on that? Yeah, it'll be okay. All right, and so I'm just going to create the maximums where we had before. The midline won't change, right? We're just talking about how far away it goes from its midline, and I'm only going to do just one period of it. And so I'll make it dotted. And so we see it still goes up and down and finishes in the same place, but it doesn't go quite as far. So the amplitude for this function is 1/2. I could also make it 5, and it would go way up to 5 and way, so you're kind of like stretching it or squishing it. So just like how you would stretch or squish a parabola, you would do this in exactly the same way. If you stretch it, it goes up much farther from the x-axis or from its midline. And if you squished it like this one, it's going to get really close to it. Obviously, if you had like 1,000th or 100th, then we would have almost a flat line here because it would be so squished that you couldn't see the differences. Okay, so this is what it looks like to adjust the amplitude of a function. Essentially, what you really end up doing, if we kind of just pick out the necessary parts, I'm just going to change this. Amplitude changes simply change the y value that I get when I place it on the x-axis. Period, on the other hand, is a little different. We'll take care of period in just a minute with cosine, right? But my main function here with the black line, this is the one thing I want to do. I need to have that memorized. I want you to practice. One of the things tonight is to just draw cosine and sine and their parent functions. Let's move on to cosine. Here we have cosine. So I'm going to draw just like before. I'm not going to take as much time to do it as last time because the basics are the same. So we're going to draw in 0. We're going to go here at pi over 2, pi, 3 pi over 2, and 2 pi. This is a good starting block. We are also going to have exactly the same height, max and mins. Okay. The difference comes in how I draw cosine. Cosine, unlike sine, starts at its maximum. It goes down, and it halfway through hits its minimum. This is more like almost like a U shape, right? So it's not V-shaped because it's not pointed, right? I'm going to go down, kind of go through the bottom. And so we come back up to the top, and we keep that pattern going. And cosine, just like sine, if I wanted to keep going with 2 pi onto 3 pi and 4 pi and so forth, the pattern would continue to change just in the same exact way. So what you see here, y equals cosine of x, right? Now, here again, a is equal to 1 and b is equal to 1. So my amplitude is equal to positive 1 and my period is equal to 2 pi. Right? 2 pi divided by 1 is just 2 pi. But that's obvious in this example where I showed you. We started at 0, and I went down, and where did I get back to where I started from? We started at the top, we hit the peak here, and it would continue on. That happened, that whole period, that whole graph started and ended over a course of 2 pi units, right? 6.28 if you're writing it in decimals. At this point, that's a distance or an angle measure you had to turn through to get this to happen. The question now is, what about period changes? What if we change the period? What if we said, what about y equals the cosine of x over 2? Now, let's write out a. So a in this case is just 1. B in this case is 1/2. This fraction, if you're not comfortable with that, that's the same thing as saying 1/2 times x, because we treat x like it's over 1. We multiply fractions by multiplying the tops together and the bottoms together to get this. This is something that you will most definitely need to know when you see fractions. Can you pull that value, the coefficient, out of it? If you cannot do that, then this is going to be a fairly difficult process for you. Okay, I think most of us have got that down though. Let's go ahead and let's figure out what my amplitude and my period are. Well, we already know that amplitude is easy because it's the same, it's 1. Well, what about period? Well, if I write out the formula, period is equal to 2 pi divided by b, 1/2. How do we multiply with fractions? Take the top part, we're going to multiply by its reciprocal. So we take the bottom, we're going to flip it over. That turns into 4 pi. So this is almost like it's stretching it horizontally. I'm going to extend that period all the way to 4 pi. Okay, we're going to go in. This is actually much easier than you think. This will be pi over, or this will be, so it's 4 pi, so 5 pi over 2. This will be 3 pi. This will be 7 pi over 2. And then we'll do here at 4 pi. All right, so I'm going to go ahead and I'm going to graph this one in black, and we're going to go just like last time. But here's how we're going to do it. If we want to graph a trig function that's got a period change, I want to kind of give you an idea about, we're going to call these increments, right? And we know that the increment of a function, of a trig function, looks like this. The increment is equal to period, not pi. The period divided by 4. This one's kind of nice because we have 4 pi divided by 4, which is just pi. So what this is telling us to do, last time I didn't tell you this because I wanted you to memorize the parent function, but sometimes we change a few things, right? And so when I'm looking at this unit, we have 1, 2, 3, 4. You have your starting point, and the first mark we have after that is 1, then 2, then 3, then 4. I'm going to be doing that, but I'm going to be going every pi to get to my marks. So here we go. We're going to start with 0, just like last time. We're going to add our maximum value. We're going to go at our first value, that's pi. The next one's going to be 2 pi. And then we're going to go to 3 pi, and then all the way up to 4 pi. Right? So I'm following along in my pattern where we went the first mark, the 25%, 50%, halfway, 3/4 of the way, 75%, and then 100%. So I'm thinking about this in quarters, all right? So 25% is my first mark. We're going by pi units here. So my second mark is going to be pi units after this one. So what is this? Pi plus 0 is pi. The second mark is going to be pi later, so 2 pi, and then add pi again, then add pi again. And so we ended up getting a graph that looks just like that one, but it's going to be stretched out a lot more. So let's look at it like this. It's going to go down like that, and up like this, and then back down. And that's how cosine would be if I stretched out. So what this function looks like, this is the y equals cosine of x over 2 function. If I can underline it without drawing through it. Okay. Now, this is going to take a little bit of practice to get through. And so make sure that you understand, if I combine those things, how to take care of that. All right, so let's do another one more, and we'll do both. Here we're going to have a function. Let's call it, we'll do sine since we have it now last time. Let's do 2 sine of 2, we'll use theta this time, 2 theta. So amplitude, A is 2 and B is 2. So my amplitude is the absolute value. Sometimes you can have a negative value up front. This can be negative. All right, so amplitude is always positive, so it's going to be 2. My period is going to be 2 pi divided by B, which is 2, which means it's just pi. So this time I'm shortening it up. Last time it was a full 2 pi. If we go back and look, you would see that it goes all the way to 2 pi. Let's write out my increment because that's the most useful thing I have. We take our period and divide that by 4. that's pi divided by 4. So, and that doesn't simplify, and I want to keep it in a fraction. So here's what I'm going to do. I'm going to draw a little axis, and I'll be honest with you, I tend to draw mine like this every time. So graph paper is nice. It helps you keep things organized, but it's really not a necessary element. If you like organized things, then it definitely is a plus. I'm going to go use my A value, my amplitude first. I don't have a vertical shift or a horizontal shift, so I'm going to go from my midline up 1, 2, and make a mark, right? So here's 1, 2, and we're going to go down 1, 2 from my midline. My midline is at 0 because I haven't moved it, because that's where the midline of the parent function is. 1, 2 up, -1, -2 down. The next part is I'm going to put the starting place for sine. If you remember, sine starts at the origin. And I'm going to make 4 marks. This is kind of a process that you'll do every time. Get your starting place, 1, 2, 3, and 4. Okay. Sine, I'm remembering back the parent function's pattern, its shape. I remember that sine starts off at the origin or at the midline, and it goes up to its maximum first. And then it comes back halfway and hits its midline again. Then we're going to minimize, going to hit the minimum 3/4 of the way through, and then back to its midline again. It's the same pattern as last time, but here's the difference, right? If I take my starting place and I add my period, right? So the beginning, the beginning point plus your period, that should be equal to the very last. So we'll say the very last step, right? So it's going to be equal to whatever number that is. Well, 0 plus what's my period is pi. So 0 plus pi equals pi. So I know that this is going to be pi. And I have 4 marks. These are my increments. I know these already. They're quarters, right? So that's actually easy to count. So 0 plus 1/4 is just 1/4. What's 1/4 plus 1/4? 2/4. 2 pi over 4. That's really just pi over 2. And then I have 3 pi over 4. So that one doesn't reduce. And then I have pi again, or 4/4 pi. And then I just draw in my curve, right? And you're like, wait, but that looks just like last time. Well, oh, that's terrible. It does. But what's important is the details that I'm going to be looking for when I'm grading your paper. Number one, I'm going to check to see if your amplitude is correct. Did they go from the midline up high enough? I'm going to check to see if their period from the starting point to ending point, is that the period of the function, right? This is pi units wide. We have a period of pi. I'm going to check to see if your increments are the correct values along your x-axis. Most often, this is where people mess up. Okay, so I know that it's quarters. We're going up by quarters here. And so I could think about it this way. Halfway from pi, 0 to pi would be half pi over 2. Half of pi over 2, half of 1 half is 1/4. Right? So you could think about it lots of different ways. And I can kind of just fill my... And this would be a successful, a complete graph of 2 sine of 2 theta or 2x or whatever. Okay? Take that to what it's worth. This is going to take a little bit of practicing, but I think you'll get it with just a couple of tries. To finish out, what I want you to do is take, you have an assignment on Canvas. There's 6 different problems. You can only see 4 from here, but there's 6 problems on this worksheet. I want you to pick 2, 1 sine and 1 cosine, right? So 1 sine and 1 cosine. I want you to graph them and do a good job, right? You can practice several of them if you want to, but do a good job and get it down right, right? If you're not sure about it, you can email me, you can ask questions, ask somebody else, right? But you're going to submit your document. You're going to take an image of your final work of the 2 graphs that you think are good. They've got the detail. They've got all the work into it. And you're going to submit those on Canvas. Some of us have had a problem getting images into a document or into an assignment. We're really going to get that done today. I'm not going to accept this in any other way. So we got to figure it out. If you've got the student app on your mobile device, that is the best way to do it. That is the easiest way to kind of get it in. If you don't have that, if you're not planning to get that, then we need to figure a different way out. So let me know if I can help. If you got a friend that knows how to do it, get with them. But whatever you do, let me know if you can't quite get that figured out, how to turn it in. If you got any questions, you can email me, and otherwise, we will see you next time.